Periodic Table of Symmetry. The title must have surprised almost all the chemistry students and most of the chemistry teachers. Well, this is anyway confined to the research article level. We don't see it in any text, at least in the Indian universities. The symmetry elements and their corresponding operations over a given chemical entity generate different point groups. These point groups could further be classified on the basis of some similarness. Here are the point groups that are given. When carefully looked at, we see that there is a C-type which contain only a principal axis, and then D-type that contain a principal axis along with C2s that are perpendicular to the principal axis. Later on we find cubic type that include tetrahedra, octahedra and icosahedral point groups. Along with these three major types, one can also find Sn, Th, Kh and infinite point groups like C infinity V and D infinity H. Since there is some correlation with D and C, these have also been included here. This is only for understanding. And all these are unique to themselves. The author of the present research article classified these point groups into 4 blocks correlating to the 4 blocks of the regular periodic table of elements. When we look at the table of symmetry point groups, these point groups are given different positions. Well, this table must only be seen as an educative and informative one, but I can say that this has absolutely no correlation with the periodic trends of the regular periodic table. When looked at the S block that is given in the pink, there is an inclusion of CS point group that contain only a plane. Later is a CI point group that contain only an inversion, after which we find SN point group where N is even. Going to the D block, which is given in the blue, it exclusively contains D type of point groups where we find DN, DND and DNH kind of point groups. Well, coming to the C block, which is given in green, it contains C type of point groups where we find C1, Cn where N can alter, CNV, CNH, and we also find an inclusion of C infinity V. So even in the case of D block, we find the inclusion of D infinity H. When any one of the group is considered, I am not referring to the point group, but it is just with reference to the periodic table. If I consider any one of the groups for any trend, we say it with respect to the axis of rotation alone. Suppose if I choose this group, the axis of rotation is only a principal axis, but D infinity H is a different from these C type of groups. Therefore, they are given in green, whereas D infinity H is given in blue. If I choose this group made by completely green, we only have one principal axis. These are also point groups that contain only one principal axis, but they also contain n C2s perpendicular to them. In the regular periodic table of elements, F block do not fit into the table and was given a special position. Even in the case of symmetry periodic table, we find such special position which is provided for the cubic point group. Since these are the point groups that contain multiple higher order principal axes, and therefore they do not match with other point groups which contain only one principal axis. So the special position for cubic point groups is justified. This is a research article that was published in Journal of Chemical Education in the year 2016. Altogether, it's a good correlation made for an informative understanding of the subject. For each point group within the table, very unique and interesting examples have been taken to raise the enthusiasm of the reader. Here you can look at various examples that are really unique. Well, this is all about the periodic table of symmetry. Any subject that creates enthusiasm in the reader's mind is also understood very well. Hope this table raised your enthusiasm. If any reader finds a better correlation, you could also communicate your article. Good luck. Thank you.